junior. And a little bit of background before I start. This is my second year in SRD, and the project that I did in SRD 1 was a computational study of classical literature, and the successful results with that and my positive experience of that led me to develop a strong interest in computational linguistics in general. And this project that I have to show you today is sort of an extension of my interest in computational linguistics to the medical field. So I hope you enjoy. So my presentation is titled Interweaving Domain Knowledge and Unsupervised Learning for Psychiatric Stressor Extraction from Clinical Notes. It's a lot to say, but I'll explain it soon enough. This is a project I did in Dr. Hua Xu's lab in the School of Biomedical Informatics at the University of Texas Health Science Center, Houston, under the supervision of Dr. Yaoyuan Zhang, Dr. Xiang Zhang, and Dr. Hua Xu. And I'd just like to point out, although there are so many Zhangs on the team, we are not actually related, unless someday genetic testing shows otherwise. You may or may not know there are about 90 million Zhangs in the world. That is 40 times the population of Houston, and there is an amazing Zhang sitting in front of me today. You know, just a little fun fact. Okay. Alright, so a major part of psychiatric practice for mental disorders consists of interviews and interpersonal observations of patients. The results are typically recorded as free clinical text in electronic health records, or EHR. Extracting meaningful clinical information from the free text by hand is difficult, laborious, and usually subjective. Recent advancement in natural language processing, or NLP, provides a new method for quantitative analysis of symptomatic manifestations with a machine-based, efficient, and automatic method. And if successful, these NLP methods can improve research in mental disorder prevention, diagnosis, and treatment. One clinically significant entity in psychiatric clinical notes is called the psychiatric stressor. Psychiatric stressors are any psychosocial or environmental factors that may contribute to a mental disorder. They can create both physical and mental stress and can cause long-term damage on both the mind and body if not treated. And some examples of stressors would be like divorce, abuse, financial hardships, death of a loved one, bullying, etc. In this example of a note segment, there are 3 stressors for the patient. She was on a difficult job, suffering repeated verbal abuse and arguments from her husband, and she was going through a separation and divorce. Identifying stressors automatically, efficiently, and objectively helps clinicians make faster and better diagnoses of psychiatric disorders. It's also important for the development and advancement of precision medicine, which depends a lot on individualized, accurate extraction of clinical information from the text. However, using NLP to extract automatically stressors is not an easy task. One major challenge is the data sparseness problem. So because stressors are highly unique to the individual and come from a very broad range of psychosocial environments, it is challenging to automatically extract them from text using machines rather than just manually extracting them. So in the study, we use NLP to extract stressor information from psychiatric notes in EHR. So our research plan is based on 2 main hypotheses. First, it is feasible to develop NLP and machine learning methods for automatic stressor extraction. Second is that integrating domain knowledge and deep learning could help address the data sparseness problem. Correspondingly, we have 2 specific aims. The first is to build a prototype NLP system for automatic stressor extraction, and the second aim is to evaluate the extraction performance by adding domain knowledge and deep learning features once integrated with the basic features or conditional random field CRF features, which I'll explain. Okay, so here's a sort of flow chart of our general study design. I'll explain it kind of generally, and I'll go into the specifics in a sec. But before I explain that, just the stressor we considered as one type of named entity. And the stressor extraction problem is addressed as an automated named entity recognition task, or NER. So first, we had a corpus of psychiatric notes that we manually annotated. And from these, common NER features are extracted first. And then stressor-related domain lexicons were obtained from online medical repositories. And this contributed knowledge-based features. And then last but not least, in order to further reduce the problem of data sparseness and to also enhance the generalizability of our NER model, word embedding features for each word were generated in an unsupervised manner from a large-scale, unlabeled clinical corpus using deep learning-based algorithms. And so once we integrated all these features, tenfold cross-validation was performed for testing a training data set and a test data set, and then the results will be shown momentarily. Before that, here's some more detail on each of the steps. So the corpus of 246 psychiatric notes was manually annotated by 2 annotators, me and my mentor, and we had a kappa of 0.75, showing relatively high inter-rater agreement. And a total of 1,225 stressor mentions were annotated from these notes. And here's just another example that shows an excerpt from a note. And there are 2 annotated stressors, his father's death and a legal battle with his sister and mother. The features were extracted from 3 sources. First, common named entity recognition features such as words or part of speech tags or clustering were extracted. Second, domain lexicons with stressor keywords and disorders were extracted from domain knowledge sources such as the APA categorization of psychiatric disorders or Medline Plus or Mayo Clinic Online, things like that, etc. And third, additional features were extracted through word embeddings from deep learning, which generated distributed word representations from large clinical corpora. Our baseline model is trained by the most commonly used machine learning algorithm for NER, that is conditional random field, or CRF, with common NER features. The baseline model was then enhanced by domain knowledge features and word embedding features incrementally. And finally, the results for each model were calculated for precision, recall, and F measures. So our project was carried out using something called CLAMP toolkit. CLAMP is a comprehensive clinical natural language processing toolkit that enables recognition and automatic encoding of clinical information in narrative patient reports. And it was developed by Dr. Hua Xu's lab that I worked in. CLAMP has high performance components. It uses machine learning and hybrid approaches and supports annotation and large corpora management. So this is like a screenshot from my laptop of just one note that I had open. You can see that the highlighted phrases are stressors that I annotated. So the way it works is you can input a label. Say you want to label something like a stressor or stressor 1, stressor 2, and then when you highlight something, it automatically pops up with a list of options for you to oh, I want to name this a stressor, and then it'll keep it there for you. And then there were 246 notes that I did. So here are the results of our machine-based extraction of stressors under the 3 models. As can be seen from the graph, all 3 models have pretty good precision. With the addition of the knowledge features into the basic CRF model, both precision and recall increased, and with the further addition of word embedding features, the recall increased and the F measure reached the best performance of 0.760. Our project is a preliminary study of using natural language processing and machine learning to automatically extract psychiatric stressors from free clinical text. Our results are encouraging. All 3 models generated reasonable precision, recall, and F measures with optimal performance with the combination of the domain knowledge and unsupervised feature learning with the basic features. However, there are several limitations to our project. The domain knowledge we included in our models can be expanded, hopefully improving both precision and recall, and a larger annotated corpus may also improve the performance. Besides, we could also further further explore unsupervised pattern or phrase learning in addition to word embedding for a better coverage of stressor-like named entities. So extracting meaningful information and concepts such as stressors from psychiatric clinical notes is important for clinicians to make diagnoses. It's important for clinicians to make diagnoses and for developing machine-based tools for automatic diagnoses. Our success at extracting stressors shows the potential of NLP for extracting mental disorder clinical concepts in general. And one future, what just happened to my screen? Sorry. One future direction is to build a system which can extract the other types of information from psychiatric clinical notes, such as symptoms, like symptoms of mental disorders. And for something like symptoms, it may be a little easier because they're so much more well defined and known versus, for example, stressors, which are very idiosyncratic and depend on the individual. But overall, more like future study in this direction will help clinicians to perform data-driven, quantified diagnosis and intervention. And lastly, I would like to give a humongous thank you to my mentors, Dr. Yang Zhang, Dr. Zhang, and Dr. Huazhu, for all of their help and guidance on this project. I cannot appreciate their help enough. I've told them so many times and I can't stop telling them. But yes, are there any questions?
Have you guys implemented this anywhere, or is it still in like the very kind of first stages?
It's still relatively in the first stages. I mean, so CLAMP toolkit was developed by the lab that I worked in, and they're still coming out with new versions. Like, there's an updated version coming out. But this, as far as I know, we are pretty much one of the first to try to use this method and implement it to study extracting information like stressors from clinical text. But if we take this somewhere and if we continue further studying, I think it could definitely make an impact. So, yes.
Do you think this could be used as a tool to track progress, like during treatment?
Definitely.
Yeah.
Mm-hmm. If it could efficiently and accurately extract stressors, it would definitely tell clinicians a lot of information about each patient, and it would definitely save time. And it could definitely help track, where, like if you see a certain number of stressors at the beginning of when they came to see you, and then you see how they've evolved over time, then it could definitely.
So this eliminates the need for the clinician, or just their?
No, because especially for psychiatric studies, an appointment that a patient makes, it has to be sort of it's like a personal interview with your doctor, because mental disorders are sort of in that category. So it definitely does not eliminate the need for clinicians, but it would definitely make their lives easier, because they see so many patients, and it's the way it's difficult for people to express what they're thinking, especially people with possible mental disorders, and then trying to decipher the words that they say, and is something that would be really helpful. Yes. Yeah, you and then.
Okay. Do you think like in the future, like if the system was used more widely, like clinicians would be like able to like use like specific kind of like word like phrases so that the machine would be able to recognize it easily? Like when they, does that make sense? No? Yeah, like standardized like phrases of words, like stressors, sorry.
Oh, yes. So standardization. So that's part of the struggle that we had in manually annotating these. So first, this is like my first time seeing like a whole bunch of real psychiatric notes from patients, and the way people talk is completely dependent on the person, arbitrary. So we had to develop a way to, like, a list of rules for annotating stressors. So like linguistically, what do you include in a phrase of a stressor? How do you standardize how it's said? So we had to the more we annotated, the more we found patterns, and we could like specify ways to say and label certain things. Because the first time we did it, our agreement rate was very low, not because we didn't see the same stressor, but because we just didn't like label it with the exact number of words or the exact way of identification. But yes, that is something that would definitely help. Yes.
So is there a way for you to weight the interpretation of these word findings into the context? So for example, the challenge with psychiatry, I guess, is that if, depending on how depressed someone is, a stressor may be contextually a very strong stressor or a very weak stressor, depending on their state of mental health at that time. I'm just wondering if there's a way to contextually score them and that it's specific to the person.
I think that is sort of helped by the addition of the knowledge-based features from the domain lexicons, because those are from like authoritative medical databases that already tell you a lot about like relationships between a patient's symptoms and a patient's behavior and what their actual disorder. And I feel like also the deep learning aspects. So to try to explain deep learning, it's imagine like trying to take the way that the human brain works and then put it into a computer. So there are a bunch of different layers of processing that happen that I'm sure somewhere in there would contribute to looking at the context, like the meaning within the words, not just like the syntactical structures from the basic features. But that's as far as I can see to be about that. So, yes, Joshua.
So, if you wanted to make it, so the point of this is to try to create unbiased diagnoses for patients. So.
Partly.
Then would it be possible at a certain point in time to, like, kind of not have the note take or take notes and just have the person speak it and have the thing just look at what they said and then analyze that?
Would be extremely interesting. That would add on a whole nother level of sort of natural language processing. It'd be like recording the person, and so it'd just be like a whole nother step. If it could accurately transfer what the patient says to the system, I think it should work in the same way. But as of right now, clinicians are, and also it's also a more personal context. A patient talking to a machine may behave differently if you're talking to like a person. But that would be nice. Yes.
Did you see great variance, or did you take clinician notes from like one clinician or multiple? And if so, did the variability in how they would state what the patient was talking to them, would it affect the whole process?
Sort of. Okay, so I'm not sure exactly like the source of the notes were from. We received them, like our project, we told them we were going to work on this and we got like a collection of real notes. But I did notice like when I was going through the notes, like some notes didn't take up my whole screen. They were like 5 sentences and nothing else. And sometimes notes didn't even have stressors. They just came in for like a refill on some kind of medication. But there were some where some that were super long and filled with patient history, family history, and then it would be sometimes like the entire thing might not be the doctor's words, it might be the patient just like in quotes, just a narrative of his life for the last 3 months. So trying to extract or label stressors was really difficult because it might be the patient speaking, it might be the doctor's thoughts, and there were other linguistic things. So, and like often there would be like a stressor that a patient would express like idiomatically, like I fell as if I got hit in the head with a hammer, and something else, and it would be like a metaphorical explanation to the doctor to express the patient's feelings, and put into a simple term it could be a stressor, but it's not a conventional way of saying it, so those are also difficult to deal with. So we made a set of rules. Are there any more questions? Okay, thank you so much. listening, and thank you to all of the SRD mentors for letting me speak here today.
So I just wanted to say one last thank you to the parents and the family that have attended, and any mentors as well. And also our students are now going to stand by their poster boards and answer any more questions that you need to have, that you have about the project. Thank you. And there's cookies and lemonade.